Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
This one type of question cost students more marks than any other on last year's papers, a two-stage probability question with a messy tree drawn badly or not at all. Sound familiar? If your tree is unclear, the examiner can't give you method marks, even if you can do the maths in your head.
In the next 12 minutes, you'll be able to build a neat probability tree, label conditional probabilities so examiners can follow your method, and use one quick check that catches most careless errors. That's your quick win for today, and you'll be able to use it in your next practice paper. Let's work through this step by step. First, what is a probability tree? Imagine a diagram that shows every possible route a chance experiment can take. Each branch carries the probability of that step. You multiply along a branch because you are finding the chance of a sequence of events happening together, and you add final branch probabilities when different sequences give the same outcome. Simple idea, but execution matters.
Example 1. Coin, then die. Toss a fair coin, then roll a six-sided die. What's the probability you get heads, then a 4? Draw the tree. First node splits to heads and tails, each with probability 1/2. From the heads branch, draw 6 branches for the die faces, each with probability 1/6. Multiply the probabilities along the heads/4 branch. 1/2 times 1/6 equals 1/12. You multiply because both events must happen in sequence.
Now, suppose the question asks, what is the probability of rolling a 4 overall, regardless of the coin? You add the probability from the heads to 4 branch and the tails to 4 branch. Each is 1/2 multiplied by 1/6, so add them. 1/12 plus 1/12 equals 1/6. Multiply down the branch, then add across the routes that give the same final event.
Example 2. A bag with 3 red and 2 blue balls, 5 in total. You draw 2 balls without replacement. Draw the tree. First split is red, 3/5, and blue, 2/5. If the first is red, there are now 2 red and 2 blue left, so second draw probabilities are 2/4 and 2/4. If the first is blue, the second probabilities are 3/4 and 1/4. To get both red, multiply down the red to red branch. 3/5 times 2/4 equals 6/20 equals 3/10. If the question asks for exactly 1 red, you add the red-blue and blue-red branches. 3/5 times 2/4 plus 2/5 times 3/4 equals 6/20 plus 6/20 equals 12/20 equals 3/5. Notice how the second probability depends on the first. That's conditional probability. Label it on the tree. Write P of second equals blue, first equals red, equals 2/4. This small label shows the examiner you understand what's happening. Here's the key difference between independence and dependence in plain language. Independence means the second step doesn't care what happened first. The probabilities stay the same. Dependence means the first outcome changes the numbers for the second, like drawing without replacement. Say that aloud as you write the labels. It helps you avoid mixing up fractions.
Now, let's talk marks. Here's where the marks are. For a standard two-stage tree question, you'd commonly see M1 for drawing a correct tree structure, M1 for writing correct probabilities on branches, and A1 for the final answer in the correct form. If you show the tree and the branch multiplications, you can often secure both M marks, even if you make an arithmetic slip. Exactly what to write. 1. Draw the tree with clear branches and labels.
Next to each branch, write the probability as a fraction or decimal, and if necessary, include a conditional label like P of second equals red hyphen first equals blue. And 3, show the multiplication for the branches you add, and then show the addition step. Box or underline your final answer. That's what wins method marks. Don't skip the check.
Common mistakes that lose marks: not labelling conditional probabilities, writing raw counts instead of probabilities on branches, and skipping the multiplication step and trying to do it mentally with no shown working. Also, watch your arithmetic when simplifying fractions. But remember, the examiner can award method marks for correct setup even if you slip on a calculation.
Quick win. A 30-second routine you can use every time. 1. Write the sample space branches clearly. 2. Box intermediate probabilities on each branch. 3. Multiply along any branch you need. 4. Add the final branch probabilities that give your event. And 5. Perform the complement check. 1 minus the probability of the opposite outcome. Say to yourself, multiply down, add across, check with 1 minus.
That phrase is a grade 9 move. Multiply down, add across, check with 1 minus. Use it at the end of a question and it catches most careless slips. Don't skip the check. Trust the process. Rapid worked example recap. A bag has 3 red and 2 blue. 2 balls are drawn without replacement. Find the probability of exactly 1 red. Step 1. Draw the tree with 2 first branches. Red 3/5, blue 2/5. Step 2. Label second stage probabilities conditionally. After red, P blue equals 2/4. After blue, P red equals 3/4. Step 3. Calculate branches. Red to blue equals 3/5 times 2/4 equals 6/20. Blue to red equals 2/5 times 3/4 equals 6/20. Step 4. Add them equals 12/20 equals 3/5. Show the 2 branch multiplications and the addition. M1, M1, A1. If you can't finish, write the tree and at least 1 branch multiplication for a guaranteed M1 and maybe M2.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. There are 10 worked probability tree questions in the show notes to practice this routine. Until next time, trust the process and nail that exam. Stay curious.